Welcome back, guys, for the next video or next concept in our electric charges and fields. Okay, if you remember in the previous classes we have discussed regarding the basics of charges or regarding what is meant by a charge and what are the properties of charges and all. Okay, in the second one we have discussed regarding Coulomb's law. Okay, so now this is the continuation part of this Coulomb's law. Okay, so just observe this, that is, as the heading itself it is there, that is force due to multiple charges. Okay, the force due to multiple charges. Okay, so you can put down the heading. Suppose actually in Coulomb's law, if you remember, we have discussed that there are only two charges there and they are separated at certain distance from each other. Okay, so instead of only two charges, okay, if there are multiple charges, okay, for example, let me take there is a charge q1 here, okay, or otherwise let me take it as q. Okay, let us assume that it is equal to q. And here there is a charge q1, there is another charge q2, there is another charge q3. Okay, the distance from q to q1, the first one, let us suppose it is equal to r1 vector, that position vector. Okay, and second body or that second charge, the distance, let it be r2 vector, and the third one let it be r3 vector. Is that okay? So here there are three charges surrounding that charge q. Is that okay? So here if you want to find the net charge, okay, for example, according to Coulomb's law, you people might have remembered it as force due to charge, force between the two charges is k into q1 q2 divided by r square. Okay, right, that is only due to one charge on the another charge. But here if you observe, here we are having multiple charges, not only a single charge, there are multiple charges. In this case, finding the force due to all these charges, it is given by, okay, force on charge q, it is equal to force due to q1, the net force on q, it is equal to force due to q1 vector plus force q2 vector plus force q3 in vector form. Okay, that means we are individually, like we are taking the summation of all the three forces, but in which form, my dear? It is the vector form. Okay, vector form means, for example, you cannot simply add like that. Okay, so there we have to take the vector addition that we will discuss. Okay, so for example, due to charge q1, if the force on this is f1 vector, due to q2 if it is f2 vector, due to q3 if it is f3 vector, then what is the net charge or force due to q1? Let us take this one. Anyway, we represent it as q1 here. This is q2 and this is q3. Okay, so then total charge on this charge, total force on the charge q is given by fq1 vector plus fq2 plus fq3 in vector form. Is that okay? So here vector addition is nothing but we are going to find the resultant of all the forces, resultant of all forces combined. Is that okay? For example, you already remember that how to find the resultant. For example, if there are two forces acting, okay, for example, on a charge, if there are two forces acting, one is F1 and another one is F2. Let us suppose both are acting at an angle theta to each other. Then what is the resultant force acting on it? F resultant is equal to root over magnitude of the resultant, my dear, root over F1 square plus F2 square plus 2 F1 F2 cos theta. Okay, same like resultant formula which you have learned in your class 11, that is resultant is equal to root over f1 square plus f2 square plus 2 f1 f2 cos theta. Okay, so let us do an example question based on this particular concept. Just have a look at this. Is that okay? So in this I am going to consider right now, for solving this particular model question, I am just considering that there is a system of charges. System means it's a group of charges you can take. Okay, in that group those charges are arranged in the form of a triangle. They are arranged in the form of a triangle. Okay, so such that that triangle is an equilateral triangle. Let me take, this is Q and this is minus Q and this is Q. Is that okay? The distance between each charge, between the pair of charges, it is always equal to R. Okay, so all the sides are equal means obviously it is an equilateral triangle. So if you want to find what is the net force acting on, which one shall we take? Which charge we will take? Okay, we will take the minus Q. Is that okay? Then we can try to do it even for this plus Q also later. First we will find the net force on, find the net electrostatic force on minus Q. Then we will find what is the net electrostatic force on plus Q also. Is that okay? First let us do with minus Q. Okay, now so this minus Q is our subject. Okay, that means on that we are finding, so I am calling it as the subject. Okay, now on this minus Q, two other charges will be applying the force. Okay, if you take this Q, this is a positive charge and here it is a negative charge. This plus Q will attract this minus Q, isn't it? Because they are unlike charges. Unlike charges attract each other. Similarly, due to this plus Q, which is at the apex of the triangle, okay, that one, that is also positive charge and this minus Q is negative charge. Again, they are unlike charges. That force, it will be acting towards the charge. It is an attractive force, right? So that's why force on minus Q, it will be acting in the upward direction towards that plus Q. Okay, now what is the angle between these two? Obviously it is 60 degree. Okay, so first let me take force due to Q, it is equal to K Q1 Q2 by R square. Is that okay? So what it will be? F is equal to K Q square by R square. You take any Q, whether it is this one or this one. Both are identical charges and they are located at same distance from minus Q. So whether it is due to this Q or this Q, in both cases it will be, what is the force, my dear? K Q square by R square. Is that okay? Now what is the resultant force on this minus Q? Force, net force on electrostatic force on minus Q, it is equal to F resultant is equal to root over how many charges are applying force here? Two charges. So one is this Q and another one is this Q. Okay, that one it is FQ whole square. So generally it will be done as F1 square plus F2 square plus 2F1 F2 cos theta. That is how it has to be done. Okay, but here F1 and F2 both are equal to how much? FQ. Is that okay? So it is equal to root over FQ square plus FQ square plus 2 FQ into FQ means again it will be equal to 2FQ square cos, what is the angle between both the forces, my dear? 60 degree. What is cos 60? What is cos 60? It will be equal to 1 by 2 root over fq square plus fq square is 2fq square plus 2fq square. Cos 60 is 1 by 2. 2 and 2 will be cancelled. Then what is remaining there? It will be equal to how much? Root 3 fq square, because 2f square plus fq square means it will be 3f square. So it is equal to root 3 fq. Is that okay? So that is the resultant force acting on minus q there. Okay. So resultant force on minus q, it is equal to root 3 times of fq, which is root 3 into, what is fq, my dear? That if we substitute here, root 3 k q square divided by r square. That is the net force on minus q. Is that clear? That is how it has to be done. Is that okay? That is, once again you see there, what have I done in this? That is, first I found what is the force due to each charge. Okay, and in which direction that force will be acting also I have taken there. Is that okay? Then I found what is the angle between them. As there are only two forces here, I directly applied the formula there. Okay, resultant formula. Is that okay? Next, like we have to find the force on plus q also, no? Just look at this. Right. Next, that is force on this plus q we will take now. On this plus q, what is the force? Let us identify. So on this plus q also, there will be two charges we will be applying the force there. Okay, that is, one is minus q and another one is plus q. Okay, so look at this. Minus q will attract that plus q, right? Force due to minus q, this is. Force due to plus q, it will be repelling because they both are like charges. Is that okay? So this is force due to plus q. And these both are, this is angle 60. Then this angle will be how much? Generally this is a straight line. Angle in a straight line is 180 degree. Then what will be this angle for the total angle to be 180 degree there? It will be equal to 120 degree. Is that okay? Now look at this. Force due to minus q. I am writing only the magnitudes, my dear. K, q1, q2 by r square, which is equal to k q square divided by r square. Once again I am saying, I am writing only the magnitude here. Is that okay? Next, because already directions we have drawn on the diagram there. Okay. Next, force due to plus q, it will be how much? K, this is q and this is also q. So again it will be equal to k q square by r square. Okay. So if you observe carefully, force due to minus q and plus q both are identical. So we are going to write this both combined as it is equal to F. Okay. Now these both forces, they are acting at what angle to each other? 120 degree to each other. Is that okay? So net resultant force again. Resultant force or force on plus q, it is equal to root over again F1 square plus F2 square plus 2F1 F2 cos theta, right? This is equal to square root of, what is F1 due to minus q? It is, again I wrote it as F there, F square plus what is F2 square? Even that is also equal to F. F square plus F square, 2 F into F, it will be equal to F square cos 120 degree. Is that okay? So what is cos 120, my dear? Cos 120 is equal to cos 90 degree plus 30 degree. Is that okay? Cos 90 plus, it will go into second quadrant. In second quadrant, cos is negative. That too, here there is 90 degree, no? So we are going to convert that into sine, which is equal to minus, sine 30 is minus 1 by 2. Sine 30 is 1 by 2. So overall the result is how much? Minus 1 by 2. So it will be equal to root over F square plus 2F square into cos 120 is how much? Minus 1 by 2. 2 and 2 will get cancelled, and if you observe carefully, this minus 1, if you write it here, so plus f square minus f square also will be cancelled. What is remaining there? Finally f square root, which is, what is f there? Again k q square divided by r square. So that is a resultant force, my dear. Is that okay? Acting on plus q. So this is how we have to identify the net force. Okay, so I'll give you an idea how to do it for a square like that. Okay, just have a look at this. So once again, if you didn't note it down, you can just listen to this by once again by rewinding the video. Okay, I'm proceeding for the next one. That is, for example, if there is a square, let us assume this is a square. Okay, I know that I didn't draw it perfectly as a square, but let us assume that it is a square there. Okay, so plus q plus q plus q, let me write this as minus q. Just as an example, my dear, a. Okay, the distance or the side of the triangle I am taking it as a. Now, what is the net force on this charge, which is diagonally opposite to minus q? Is that okay? Look at this carefully. How to do only I'll be telling. Is that okay? Listen carefully. You can try it later. Okay, I'll tell you how to do. You can try it later. Okay, so the thing is, first plus q and plus q will repel each other, so it will be, that repulsive force will be this way. Is that okay? Next, due to this plus q, it will be acting upwards because they will repel each other, plus q and plus q. Is that okay? Now this force due to plus q and plus q, they are acting at what angle to each other? Exactly 90 degree to each other. Okay, because the side of the triangles make 90 degree to each other. Okay, so 90 degree means, again you can find what is the resultant there using that equation, f1 square plus f2 square plus 2f1 f2 cos 90. What is cos 90? It will be equal to 0. Then that resultant will be this way. Is that okay? That is that resultant. Okay, then, but due to this minus q, which is at a distance of, what is the distance as the diagonal of a triangle? This side is a and this side, if it is also a, then this length will be equal to root 2a. Is that okay? Now this minus q will attract the plus q in this direction, that is opposite to that resultant force. That is, so here we are going to apply k q1 q2 by, what is r here? Root 2a whole square, like this. So this resultant force and force due to minus q both are opposite to each other because minus q is attracting it, whereas plus q charges are repelling it. So the net force will be equal to, on this plus q, it will be equal to resultant force minus this resultant force minus force due to minus q, because they both are acting at opposite to each other. Generally in resultant, if they are acting opposite to each other, you can take that resultant is equal to f1 minus f2. If there are two forces, one is f1 this way and another one is f2 this way, which is acting exactly opposite at 180 degree to each other, then what is the resultant, my dear? f1 minus f2. Therefore net force is equal to resultant force minus f minus q. Resultant means force due to plus q. Is that okay? Right? So you please try to do this question. Okay, this is one of the important model and you will be having this an example question in this based on this in your NCERT textbook also. So please try it. Okay, and when time is available, I will be explaining that also in the next class most probably. Okay, so here I want to convey one thing to all the students of class 12 here. Okay, so generally most of the students who are having the difficulty in understanding physics, okay, or who are trying to learn more or better in physics, you don't take that whole chapter at a time and start reading it. Okay, you have to take the chapter like part by part. That is, for example, initially I have taught regarding the charges, basics of charges. Then I have taught regarding the Coulomb's law. Okay, then I am teaching regarding the force due to multiple charges. Okay, so why am I actually giving only that small videos, like only for small topics, is when you are learning it in a small parts, no, you can understand it a bit better. Okay, suppose at a time if I bring the whole chapter at a time and if I put it in front of you, it will be slightly confusing, and by the time I am discussing the last concept, you might not remember the first concept. Okay, so for that reason I am giving short videos for each concept, so I think you people can follow it. If there are any suggestions you want to give, you just put it on the comment box. Is that okay? Right? Thank you all. Let us meet for the next video with few numericals and the concept of electric field. Thank you. Bye bye.